Hi everyone. My topic today is what's new in middleware monitoring in Enterprise Manager. My name is Yutaka Takatsu. I'm one of the product managers in the Enterprise Manager product management team. Here is today's agenda. We will start with an introduction, what is Kubernetes and why it is important to WebLogic customers. We will then dive into how to monitor WebLogic deployed on Kubernetes, which is the main topic in the session. Here we will discuss the challenges and solution details. Also, how to secure the solution, what happens when the pods are restarted, and how you can diagnose JVM. Lastly, we'll introduce our newly developed non-Oracle middleware plugins. It's been already some time since more and more organizations are planning to or are already moving their WebLogic into containers, especially Docker and Kubernetes as a part of the middleware modernization. Then what monitoring solutions there are? First of all, there is WebLogic Kubernetes Exporter, which is one of the toolkits. It enables a collection of the WebLogic metrics and exports to Prometheus. Then you can use any dashboard utility such as Grafana to visualize the metric data. Alternatively, you can use Application Performance Monitoring Service in Oracle Cloud. This is an Oracle Cloud service that collects traces and spans from the WebLogic instances and helps you analyze the application status and performance by providing end-to-end monitoring and diagnostics. So if you are new to Oracle's monitoring solutions, and especially if the application runs in the Oracle Cloud, APM is a recommended solution. Another solution is to use Oracle Enterprise Manager Cloud Control. For existing Enterprise Manager customers who are already familiar with the tool, you don't have to go learn a new monitoring tool for targets deployed in Kubernetes. You can use the same monitoring solution, which is the Enterprise Manager you have been using for WebLogic deployed on Kubernetes, along with your existing deployments in a traditional data center. There is one condition to note. You must be using WebLogic Kubernetes operator to manage the WebLogic domain. I would like to explain more details on the solution in this session. So let's quickly recap what Kubernetes can do for you. Kubernetes is the most popular container orchestration solution available today. It has a set of open source APIs that allows you to configure how and where you want to run or schedule to run your containers. Using Kubernetes, you can quickly run an instance of your application in a cluster and scale up and down based on your available resources. You can also extend the Kubernetes API with custom resources using custom resource definitions or CRD, which allows you to introduce your own API into the cluster. In that sense, Kubernetes is portable, scalable, and extensible. And WebLogic has a solution that helps you to migrate your WebLogic domain to Kubernetes. That is WebLogic Kubernetes Operator, which provides automation to the WebLogic operations on Kubernetes, such as provisioning, patching, and scaling. It extends the Kubernetes API and designed to accomplish the similar responsibilities to which a human operator would perform in a traditional data center deployment, such as starting and stopping the servers, for example. When the operator is installed, it creates a custom resource definition, which defines a WebLogic domain type in Kubernetes. Once the domain type is defined, you can manage the domain using kubectl command, just like you do for any other Kubernetes resource type. The WebLogic operator always looks at the domain custom resource and tries to match the actual state to the desired state. So if one of the managed servers goes down, it tries to create another to match the number of replicas defined in the domain custom resource. Here is how it looks like more realistically in the actual deployment. In this example, there is a WebLogic domain defined with admin server and 2 managed servers, which are provisioned by the WebLogic operator in a Kubernetes cluster. And this is the environment we would like to monitor using Enterprise Manager. However, you cannot just directly install EM Agent on the WebLogic host as you would do in your on-premise deployment. Let's see what are the challenges. If you follow Oracle recommendations, by default, WebLogic domain and the server components are created in a private subnet, with access limited to its own virtual cloud network or VCN. There is no access allowed from the outside of the network, which means that Enterprise Manager that resides in a different VCN won't be able to install EM Agent to the container host. Even in a case you manage to manually install the agent to the containers within the pods, there is still a problem as Oracle Management Service, or OMS, cannot access the agents because they are in a private subnet, while OMS needs to communicate with the agent bidirectionally. So there are security constraints in the Kubernetes setup that is purposely making the environment secure. Another challenge having EM agent in the pod is when managing the lifecycle of the agent. Kubernetes pods are transient in nature, so if a pod fails, the WebLogic Kubernetes operator automatically creates a new replica of the pod to continue the operation. However, in this case, EM agent won't be automatically reinstalled to the pod. You will lose the agent when the pods are recreated. If you have an agent in a pod or in the container, you must go through the installation and discovery process manually every time the pods are destroyed and regenerated. So these are the problems or challenges you would expect when installing EM agent into the Kubernetes pods, and that is why we need a different approach. Next, we will talk about the solution. Our solution to resolve these problems is to use the Kubernetes load balancer service. To do so, first you will create a new private subnet within the VCN. Then within the subnet, create Kubernetes load balancer services that connect to WebLogic servers. The way it works with a load balancer service type is that the service becomes accessible externally through a cloud provider's load balancer functionality. So in this case, underneath this picture, it creates a load balancer service in Oracle Cloud, which will route the traffic to the cluster IP endpoints that is configured in the load balancer service, and use that service to connect to the WebLogic servers in the Kubernetes pods. And you will specify a port in each load balancer service that EM agent can access. In this example, the port numbers are the same with those of the WebLogic servers. And this can be done by creating and applying a YAML file. In the port section, 7001 is specified for the port and the target port to connect to the admin server. There is also the port 30012 specified for the T3 channel, which is set to connect to JVM. Please be aware, because of the service are in the private subnet, the external ports are only accessible within the VCN. The next is to install an EM agent. Create a public subnet within the VCN. Then you can use SSH to push the agent binary from the Enterprise Manager console and remotely install the agent in the same VCN with a Kubernetes cluster. This way, it can connect to the load balancer services and get the metric data from the WebLogic servers. Lastly, configure the agent port so that it can communicate to the Enterprise Manager that is located outside of the VCN. Using this method, you can configure the EM agent to connect to the load balancer services instead of directly communicating with the WebLogic servers in the Kubernetes pods. As briefly mentioned, the access to the pods are configured to the minimum required. The load balancer services are set up in a private subnet, and access to them is restricted only within the VCN. So you will not be able to access the load balancers from outside of the VCN. You can also restrict the access to the agent port 3872. This can be done by configuring the CIDR in the public subnet, allowing access only from the Enterprise Manager host. So you can securely configure the access to the WebLogic servers as in this diagram so that only through the Enterprise Manager you can access the information from outside of the VCN. Then what would happen when the pods or the worker nodes are restarted or regenerated? In this model, monitoring continues because the EM agent do not reside in the pods. During the time when the pods are restarting, EM agent sees the targets are down. The target status is down in the Enterprise Manager console. When the pods are restored, the load balancers automatically reconnect to the new WebLogic server pod. The target status in the Enterprise Manager is back to up again. Reinstallation or the reconfiguration of the EM agent is not required because it resides outside of the pod or the domain. Also, because Enterprise Manager regards the old server and the new server as the same target, the historical metric data of the target is preserved. So you can continue to use the historical metric data for analysis using the same target. Once you complete the setup, you can log into the Enterprise Manager console web UI and discover the WebLogic domain and the related targets using the standard Fusion middleware discovery process. Please note that because there's no agent installed in the WebLogic containers or pods, you'll need to use the EM agent which you installed in the same VCN with the cluster and remotely discover the targets. Also use the IP and the port of the load balancer service that is connected to the admin server as the discovery parameters, as in the example screenshot displayed. This is the Fusion middleware discovery page in Enterprise Manager console, where I enter the IP and the port of the load balancer service. And upon the successful discovery, you'll see the WebLogic targets discovered and started the monitoring in the Enterprise Manager console. And optionally, you can enable JVM diagnostics on the WebLogic servers on Kubernetes and conduct deep dive analysis on your JVM. Using JVMD, you can find problems like the slowest request or slowest method, which one is waiting for I/O or database calls, or which ones are using a lot of resources. It has complete visibility into JVM stack, where you can drill down the performance issues to the method or even a line number in a Java class. JVMD consists of JVMD engine, which is a core analytical portion of the JVMD, and JVMD agents, which are the data collectors of the target JVM. Here you can manually deploy JVMD agents inside the WebLogic servers and collect real-time JVM monitoring data. The agent transmits the collected data to the JVMD engine directly using one-way HTTPS connection. Note that JVMD does not use an EM agent, having its own channel to communicate with the Enterprise Manager. As a limitation to this model, the JVMD agent deployment will be lost when the pod is regenerated. Therefore, reinstallation of the JVMD agent must be repeated every time when such event happens. If you want to have the JVMD agent persist in the WebLogic server, you can deploy it in the Docker image of the WebLogic so that the JVMD agent is pre-deployed when a pod is created. For more information, we have a hands-on lab workshop in Oracle Help Center, which covers the topics discussed in today's session. This is a workshop having step-by-step tutorials on enabling the monitoring of WebLogic on Kubernetes in the Oracle Cloud using Enterprise Manager. Now let's shift gears and talk about the new non-Oracle middleware plugins. In a future release of Enterprise Manager, we are planning to introduce brand new non-Oracle middleware plugins. These are the plugins for third-party middleware server target types. They are Apache Tomcat, Microsoft Internet Information Server, JBoss Enterprise Application Platform, and IBM WebSphere Application Server. When these plugins are released, you can download them from the self-update in your EM instance. To discover the target, go to the Setup menu and select an option to add target manually, just as you do for any other metadata plugins. And these are not just an update to the plugins that we currently have. They are newly developed metadata plugins. However, they maintain the same flow as the current plugins. So you can discover a target, configure and monitor the targets in a similar way you do with the current plugins. And they support the latest target versions. The Apache Tomcat plugin supports versions 8, 8.5, 9, and 10. The IIS plugin supports version 10. The JBoss EAP plugin supports versions 6 and 7. And the WebSphere application server plugin supports versions 8.5.5 and 9.0. These plugins provide updated out-of-box performance metrics and also the configuration settings metrics for the supported target versions. The plugins also support the information publisher reports for each target type. And there are pre-configured jobs that allow you to start and stop the target server remotely from the Enterprise Manager console. And as for the IIS and Tomcat plugins, the upgrade is supported. So if you already have targets monitored by the previous version of the same plugin, you can upgrade to the new plugin and the historical monitoring data will be preserved. Please note, however, the upgrade is not supported for the JBoss and WebSphere plugins. That is because currently they are a part of the FMW plugin, while the new plugins are metadata plugins. So you will need to rediscover the target to use the new plugin, but you don't have to remove the old target as it can coexist with the new target in the same EM instance. This concludes the session for What's New in Middleware Monitoring in Enterprise Manager. Thank you for watching.